Now that we've practiced factoring expressions, let's try solving some equations now that we kind of have a better grasp of the factoring, hopefully. So we have x squared plus 4x equals 45. I need to set that equal to 0. And then I need to factor the trinomial equal to 0. I'll have an x and an x. I need something that will multiply to negative 45 and add to positive 4. I'm going to go with 9 times 5, which is 45, and hope that it works. Now, you might be thinking, why does she always figure out the right factors? Honestly, it's practice, because I've become very comfortable with seeing the factors when I see a number, a big number. But it's not always been that way, and trust me, sometimes I still get it very wrong. So 9 and 5 gives me 45. I need one to be positive and one to be negative. Since my middle term is positive, I know that my bigger second term must be positive, and my smaller second term must be negative. Now, if I want to find the solutions, I have to set each binomial equal to 0 and solve for x. X equals negative 9 and x equals 5. Those are my two solutions. Now let's take a look at x cubed minus 2x squared equals 63x. I'm going to subtract 63x from both sides, and that gives me x to the third minus 2x squared minus 63x equals 0. Now I can factor my trinomial, and I have a common factor of x that I need to factor out. So I have x times x squared minus 2x minus 63. Now this x squared minus 2x minus 63, that's the trinomial I need to factor. The common GCF, x, got put out in front. So now I'll have an x and an x, and I know I need a 63 as my product of whatever the two numbers are I put in here. Let's do it this way. I know that 63 is divisible by 3. That would be 21. I know 21 is 3 and 7. So it looks like 9 and 7 would be the two numbers that would be convenient, that will get me what I need, 9 and 7. I need the bigger number to be negative and the smaller number to be positive. Now I'm going to take my factors and set them equal to 0. And then I'm going to solve for x. X equals 9 and x equals negative 7. Now let's take a look at this last trinomial on this row. This is an equation. It's already been factored, which is unfortunate because we're going to have to bring this 14 over. So now we have x minus 3 times x plus 2 minus 14 equals 0. Now notice this doesn't fit the form of a trinomial, so we have to FOIL the two binomials first before we can combine it with the negative 14. That will give me an x squared minus x minus 6 minus 14 equals 0. Now I need to combine those last digits. That will give me x squared minus x minus 20 equals 0. Now that it's a trinomial, I can factor it into two binomials, set the binomial factors equal to 0, and solve for x. I'll have an x and an x, and two numbers that will give me negative 20 would be 4 and 5, one positive, one negative. I need the bigger factor to be negative so that the middle term is negative x. That means that negative has to be with the 5 and positive has to be with the 4. So my two solutions are x equals 5 and x equals negative 4. We are now going to look at how we could apply these same factoring techniques to functions. Now remember, when we're trying to solve for the zeros on a function, we are replacing f of x with 0. So in place of the f of x, we're saying the f of x is equal to 0. Our output is 0. So then, when f of x equals 0, we have 0 is equal to, and then we have to factor our trinomials. X and x, 9 and 5, and then we need the bigger number to be negative. So -9, +5. Similarly, we have an x to the third minus 2x squared minus 3x. I'm going to factor out the common factor of x, and we get x squared minus 2x minus 3. Now let's factor the trinomial x and x minus 3 plus 1. Hopefully you're starting to see a pattern here. Now we're going to set these. We should have done that with the previous one. Let's solve the first one. I got excited to move on to the next one. X minus 9 equals 0, so x equals 9. X plus 5 equals 0, so x equals -5. Those are my two solutions, or zeros, of the function. Now this second one here that I worked out, this has 3 factors, so we have to set all 3 factors equal to 0. This has x equals 0, x minus 3 equals 0, and x plus 1 equals 0. So the first one is just x equals 0, the second one is x equals 3, and the third one is x equals -1. Now let's try f of x equals 3x squared plus 21x plus 30. Notice that we are replacing the f of x with a 0, and we're looking for a greatest common factor, which happens to be 3. So 3x squared, 3 times the quantity, x squared plus 7x plus 10. Now we're going to factor that trinomial, x and x. And let's try 2 and 5. 2 times 5 gives me 10, and 2 times 5 will also add to 7. Since all 3 terms are positive, I know my binomials will have 2 positive signs. So my two solutions are x equals -2 and x equals -5. Factoring higher powers. Now these have the same patterns as any other factorizations, but their powers are usually doubles or triples of the original powers that we're used to seeing. If we look at 16x to the 4th minus y to the 4th, this has a difference of 2 squares written all over it because the middle term is missing. But the powers are higher. So let's just do what we know about differences of 2 squares and see what happens. We're undoing the process of difference of 2 squares where you have like an a plus b and an a minus b pattern. But now instead of a squared, it's 16x to the 4th. So the square root of 16 is 4. And the square root of x to the 4th is x squared. You can always check this by foiling them back together. And then we need one positive and one negative second term. Again, square root of y to the 4th is y squared. And so we've basically gone backwards with our pattern. Instead of squaring them to get the term given or the expression given, we're now going the other way because we hopefully see the pattern. Notice that this first one is plus in the middle, so we can't really do anything with that one unless we know about complex numbers, which we haven't covered yet. The second one is also a difference of 2 squares, and so we can factor this one further. We'll just drop the first binomial factor down, leaving it as is, and then we will continue to factor the second binomial into two separate binomials. We'll have a 2x and a 2x. That will give me, if I were to FOIL it, back 4x squared. And y would give me a y squared. But one has to be a positive sign, the other has to be negative. Now, you might be thinking, I don't really believe you. Go ahead and multiply them. It'll come out the same. This last one here is 2a to the 4th minus 32y to the 8th. And I'm going to factor out a common factor of 2. That will give me an a to the 4th minus 16y to the 8th inside the parentheses. This also has a difference of 2 squares pattern to it. And so I'm dropping down my factor, my common factor, GCF, and then I have a to the second, 16 is a perfect square of 4 and 4, and y to the 8th is a perfect square of y to the 4th and y to the 4th. And then I need a plus and a minus. Again, the pattern holds just like before on the previous example. We're going to leave the sums alone and we'll just rewrite them. 2a to the second plus 4y to the 4th. And in the second binomial, we can factor it further. We'll have an a and an a 2 and a 2, a y squared and a y squared, and a plus and a minus. Now, it might be best to refresh your memory here because remember, a squared minus b squared is the given difference of two squares, and it factors to a plus b and a minus b. It's the square root of the first, square root of the second, and the signs are different in the binomials. Hopefully that makes sense.